ముందుగా ప్రియమైన విద్యార్థులకు మరియు వారి తల్లిదండ్రులకు నమస్కారం. నా పేరు కె వెంకన్న జూనియర్ కాలేజీలో చైర్మన్. నేను ఈ రోజు 10th క్లాస్ విద్యార్థులను దృష్టిలో పెట్టుకొని మాట్లాడడం జరుగుతుంది. అది ఏమిటనగా, మనందరికీ తెలుసు, గత 2 సంవత్సరాలుగా కరోనా కారణంగా విద్యార్థులు ఎటువంటి పరీక్షలు రాయకుండానే పై తరగతులు పంపడం జరుగుతుంది. ఫలితంగా ఐఐటి జేఈ మరియు నీట్ లాంటి జాతీయ స్థాయి పరీక్షలను సాధించడం కష్టతరం అవుతుంది. దీనిని అధిగమించడానికి మరియు 10వ తరగతి పరీక్షలో అత్యధిక మార్కులు సాధించడానికి నేను మీ ముందుకు కె వెంకన్న జూనియర్ కాలేజ్ ప్లాట్ఫామ్ ద్వారా అనుభవజ్ఞులైన అధ్యాపకులచే ఉచిత వీడియో క్లాసులు, హ్యాండ్ రిటన్ నోట్స్ మరియు గత ప్రశ్నపత్రాల సమాధానాల విశ్లేషణ ఇవ్వబడును. కాబట్టి నేను విద్యార్థులకు చెప్పదలుచుకున్నది ఏంటంటే, ఈ ఉచిత వీడియో క్లాసులను మరియు హ్యాండ్ రిటన్ నోట్స్లను క్లాస్ రూమ్లో కూర్చొని చదువుకున్నంత సీరియస్గా చదువుకోవాలను. ఇంకొకటి ఏమిటనగా, ఈ యొక్క క్లాసులు విన్న వెంటనే అర్థం చేసుకొని ప్రాక్టీస్ చేయవలను. ప్రాక్టీస్ చేయడం అంటే కేవలం చదవడం కాదు, పేపర్ మీద రాయవలను. అలాగైతే గుర్తుండిపోతుంది. దీంతో పాటు మీ యొక్క నాలెడ్జ్ని పరీక్షించుకున్న కొరకు త్వరలో ప్రీ ఫైనల్ పరీక్షలు కూడా నిర్వహించబడు. ఈ యొక్క అవకాశాన్ని సద్వినియోగం చేసుకోవాలని 10th చదివే విద్యార్థులకు విజ్ఞప్తి చేస్తున్నాను.
Hello my dear students. Then we have been discussing about that electric current. We discussed so many topics under that chapter electric current, and in the previous video also we discussed about the Kirchhoff's laws, series and parallel connection. Mostly in electricity we get so many problems based on series and parallel connection of resistances, Kirchhoff's laws, and finally the commercial units by the electric current department, electricity department. And these are the 3 varieties of the problems we get here, mostly from that. And very rarely we get the problems based on resistivity. Today we see that the problems on series and parallel connection of resistances, and earlier we have seen based on electric resistivity. Today we see the problems on these connections only. Before that, let us see the formulae. We see the formulae. With this, you see the formulae. In this formulae, what we have? In this formulae, we have first one effective resistance in series connection, R1 plus R2. This is in series connection. When we come to that, the second one, Rp, there we get based on resistances, how many resistances are there, R1, R2 by R1 plus R2. These are the resistances which are connected either in series or parallel. The same formula we can write in another way, that is what Rp we can write it as R effective, means Rf also. This we can write as what, 1 by R1 plus 1 by R2. On solving the same, we get such kind of the formula. Series resistance, the same, there is no change in that, but only in the parallel connection this kind of the formula we can use. This and this both are same, that without reciprocals we are using directly the resistances, but here we are writing the reciprocals of the resistances, no other change. We see that some problems in this, and before that one point I want to say, in series connection of resistances, the effective resistance will increase, and in parallel connection of resistances effective resistance of the total combination decreases than the original resistor to which other resistors are connected in parallel. This you have to remember. Sometimes they may ask the problems based on both together in one problem only, series and parallel connection. Before going to see that, we see one problem from your textbook only. That is what example 2 in the state syllabus of syllabus textbook in the page number 195. There, based on that only, we are going to check all the other kind of the problems. Then by taking those as an example problems in this, we will go to that, we solve. There are 3 resistors R1, 4 ohms and 8 ohms are connected in series in a circuit, and among them one resistance is not given. Here we have the example problem we are going to check now. Example problems.
Students, my name is Vishal Sharma and I did my BTech from IIT Kanpur in Electrical Engineering. I have an experience of more than 12 years in preparing IIT JEE aspirants for this examination. Under me already more than 100 students have cracked this IIT JEE examination. Right now I am associated with K. Venkana classes. Now K. Venkana classes, for the first time in Hyderabad, it has brought your top Delhi, IIT and NIT faculties. Now what are you waiting for? Come and join us and realize your dream of getting into IITs.
Here we have, as per that, 3 resistors are there. 3 resistors are connected, 3 resistors in series, 3 resistors in series, 3 resistors in series. Now these resistors are connected in series. What are those 3 resistors? One is R1, 4 ohms, and finally 8 ohms. Where we have there the effective resistance also. If this effective resistance is how much they give, here we have this effective resistance is what, 20 ohms. 20 ohms. Now in that, let us use this formula. There what formula we have? We know R effective is equal to, what is that? We have to use the formula because this is in series connection, R1 plus R2 plus R3. How many resistors ever we are connected here? And in all these 3 resistors, then we have to write them as sum of the resistances only. Here let us substitute these values. Here this is 20 ohms plus R1 as it is, I am sorry, 20 ohms is equal to, this is 4 ohms. The resistance 1 is what? This is we are taking it as R1 plus what is that R2? 4 ohms plus R3 8 ohms. Then this implies R1 is equal to 20 minus 4 plus 8, 12 ohms together. We get this as what? 8 ohms. This is that the resistance is what we can connect here. Then what is connected in this series combination of the resistances? Now we will see that another problem where we can see 2 resistors are connected in parallel in a circuit, and there is these 2 resistors are which are connected in parallel. There we have to find out that R1 resistance This already you know, and how can we solve? In parallel connection, the same process. If those are connected in parallel, what happens to that? There we can see that one more example in parallel connection. In the same process we can do, we can see the same process. What are those the same process here? We can take these all the resistances. R1 and R2 are connected in parallel. The resultant resistance is 3 ohms, R1 and 12 ohms. There two resistors, two resistors in parallel. Two resistors in parallel, you have to remember this. What are those resistors values? One is R1 and another one is what? There we have to take that 12 ohms. This is 12 ohms resistance is connected. There we have R effective value also we have, that is taken as what? R effective value is 3 ohms. This is that resistance value what is connected here. Now, in that what is to be found here, we can understand here, that is R1 only we have to find. There what shall we do? We know R effective, let us take it as R effective as RP, because it is connected in parallels and we can understand. We know that already we have seen. Let us use that reciprocal form only, so that all, because you are familiar with this kind of writing, plus 1 by R2. 1 by RP is what? R effective or RP, the same we can write as RP as a parallel connection. There we can take it as 3 ohms plus, is equal to 1 by R1 as it is plus 1 by R2 is 12 ohms. We can write this formula in this form by using that original formula. We have to find out 1 by R1 is equal to 1 by 3 minus 1 by 12. 1 by 3 minus 1 by 12. Then here it is very clear that LCM is 12. Then there we can get this as 4 minus 1. There it is equal to 3 by 12. 3 by 12, 3 ones, 3 fours is equal to 1 by 4. Therefore, here this is 1 by R1, then we can understand R1 is equal to 4 ohms. R1 is equal to 4 ohms. This is that value we can get in this when unknown resistance value which is connected in parallel connection with another resistance. Let us see this first and second, first one is series, second one is parallel. When both are involved in any connection, what about its effective resistance? That let us find out. Here we have and 3 resistors are connected such that 4 and 12 are in series with 7 ohms resistances. We can see that example, one more example. Here, there we have that different kind of the connection. This is all together connected to a battery. There let us see that here the connection 4, 12, 7, 4, 12 and another resistance is in 7, 4, 12, 7, 4 ohms, 12 ohms, 7 ohms. These are connected like this. Let us take these resistances as R1, R2, R3, this is voltage. Let us see in that, first let us simplify this circuit. What we can get, like, let us see now. So, first series combination RS, R1 plus R2, I am sorry, this is in first 2 are parallel connection. In this parallel connection, we have to take this as what you are familiar with, that only we see now. There, that only we see here, that is what here. This is 1 by Rp is equal to 1 by R1 plus 1 by R2. How much we get here in this when we solve them? This is equal to 1 by 4 plus 1 by 12. This is nothing but 1 by Rp. Then when we solve the same here, the LCM is 12, it is very clear. This is LCM is 12. LCM we are getting this, we are taking this as a 12. What we have to write here? 3 plus 1. This is what 1 by Rp. Then if you write Rp, then reciprocals of these only we have to write. 12 by 4 is equal to 3 ohms. Now, it is very clear that the effective resistance of this parallel combination is 3 ohms. Now, this 3 ohms, this connection is in series with the 7 ohms. There we can see here what we can write. This is equal to, then we have effective resistance or P in series with another resistor. This is that the combination. Here what is it Rp total combination? That is 3 ohms. 3 ohms Rp. Here we have R3, this is 7 ohms resistance. Then what we can take here are, yes, total or effective resistance of these both. We have to write that as what Rp plus R3. This is what 3 ohms plus 7 ohms. Totally how much it is? 10 ohms. Means the effective resistance of the total circuit is what? That is 10 ohms, which we can see here. 10 ohms. Like this we can solve the problems. While doing that, we have to write very clearly all this formulae. In examination, while you are solving, it is better to what is that, if you keep this in box. Whenever we write like that, it will be very effective if you keep this all the formulae, highlighting them and keeping that in box, like this kind of the formulae. No, there we have to use that mathematics, some language is there, that is only we know. Here we have, it is given, solution, this kind of the words are very, very important. See that after solving that, then we are going simplifying the circuit, then we are writing the final formulae. Like this continuously, if you write like a narration of a story in the problem, we can come to that conclusion at last. See that here we are writing that what we have to find. Here we are writing that what we have to find. Here finally we got what is the effective resistance, that is that finally we have to write. This is the way what we have to solve the problems. In all this, I hope you understood this video. This is that very much useful for you, and while solving this kind of the problems, we are going to see that Kirchhoff's laws problems one by one with the help of the rules which they used in this video. Okay, thanks for watching this video. We'll meet you in this next video with some problems based on Kirchhoff's laws.